Welcome back to the discussion, Federal Insights, What's Next for Intelligent Automation and the Federal Government, sponsored by Appian on Federal News Network. My guest today is Michael Beckley, founder and Chief Technology Officer at Appian. I'm your moderator, John Gilroy. Well, all through the federal government, if you look at databases, data storage, whatever you want to call it, a lot of it aren't clean. They're not clean in the federal government, they're not clean in the commercial world either. So how can a process be automated if you're starting off with a flawed data set?
So the important thing to keep in mind is there are a lot of different techniques to automate. And robotic process automation is an exciting new technique that we have incorporated into the Appian platform that allows us to even reach into those systems that have unclean, inconsistent data. They have no established application programming interfaces for automatic connections and web services, the more modern techniques. So with RPA, we simulate a human logging into the system. Only once we've recorded that login, we can script it to go much faster. That's why we call it robotic process automation. It's automated, it's repetitive, and those bots can, by simulating a human, go into systems, log into them just like a human would, and interact with them and pull out that information. And once we've gotten the data out, we can put it in front of a human after we've aggregated it, after we've sorted it, after we've filtered out a lot of the noise, and allow the human to just take advantage of their unique insights as the human mind can so much better than a machine, adapt to the change, and simply do what little 10% of work is required to finish the job.
So at what point in time is a data set ready for workflow? I mean, is there a number there, 85%, 70%, or how do you judge?
Well, we don't judge it by a percentage basis. We judge it by what the mission is and what the work you're trying to accomplish is, and can the data match that need. So for example, any legacy system is likely to have data errors and mistakes and inconsistencies, but it's not likely to stop the ability for most of the work to flow through unimpeded. It's just necessary to have machine learning to check for variance, and then an ability to put that into a human workflow where a supervising person can actually validate that a change needs to be made and make it right at the time it's needed.
You're using a very strange word here, humans. I mean, what's that got to do with computers and data processing? So what you're saying, it's really not just a data science problem. It's got to include humans as well.
Yeah, and it's not just about putting humans in the loop. It's about augmenting humans and designing systems around humans. The dream of a lights out factory, of a completely automated straight through pipeline isn't gone. It's just that if you understand from the start that our tools are fallible, our machine learning and AI techniques will always be inconsistent, they'll always have some mistakes, then you can step back and say, wait a minute, I don't need them to be perfect if they're just helping a person. People aren't perfect either, but now the machine can supplement the human and in all kinds of useful ways. So if you're processing eligibility and enrollment applications, well, most of them will probably fit into a standard pattern, and a machine will be able to input addresses and names and basic income information and address and demographics right into a system without any complexity. But it's when those things come in a different format, they come in from a different agency, they get transferred in handwriting, that a human will have to supervise and make sure that the application gets routed appropriately.
I've had the pleasure of sitting down with a lot of data scientists over the years. Mm-hmm. And first of all, they love hot sauce and they love to argue. They'll argue about the meanings of words and go back and forth, and they'll just spend hours in some meaningless definition that maybe not be very practical in the real world. I've heard people argue data lakes versus data warehouses. Now, sure. You get a warfighter sitting in a mountain somewhere, they don't want entertaining repartee of this discussion. They want to make a decision. So how can RPA, robotic process automation, help that guy in the mountain somewhere?
Well, so RPA on its own isn't going to help so much, but when it's unified in a full stack of automation where we design a human workflow and provide the right information to decision makers, to the warfighter, to the mission owners, and then we provide robotic process automation to reach into systems that were previously inaccessible, that didn't have APIs, application programming interfaces, to access, that didn't have web services. And so now there's more information available to them. And then we can use machine learning and artificial intelligence to process more of that data faster. And only where there is an exception, there's something out of the ordinary, can we present that to the human for their supervision. And they can always peer in and see what the system is doing. So if you're looking at automating maintenance of airplanes, then of course artificial intelligence is going to help us predict failures in parts by looking at the whole system in a way a human might not. But that isn't necessarily on its own going to be what we need to have a full maintenance workflow without incorporating the human in the loop and using tools like RPA and human workflow to allow that person to understand the signal from the noise, to see what's really a part that's going to fail, and to be able to access the maintenance depot and get that shipment to them in time so that plane keeps flying.
And the federal government's presented with unusual challenges. Sometimes people are smoking cigars over at FEMA, and sometimes they're working 24 hours a day, 7 days a week. Same thing in the military. Sometimes there's just a regular amount of problems, and sometimes they're working 24 hours a day as well. So the problem I'm getting at is scale. So if you have a finely tuned little RPA system that seems to be working, how can it accommodate drastic scale increases that can't be predicted?
So that's an important point, John. We deal with and have to prepare for in government crises all the time, and so we can't assume that we have the luxury of training up an entirely new workforce to respond to every problem. And so what you do is you model out how that work needs to be done at any scale, and then automation techniques like RPA can allow you to immediately add bots to process higher amounts of workload. And this allows you to augment a small set of human experts and actually have them operating as if they were thousands of humans. And so that's how full stack automation can allow the government agencies to fulfill their missions no matter what storm, no matter what crisis around the world takes place and challenges them.
I think in Missouri they have the show me state, so I always do the show me question of, okay, can you give me some examples from agencies that are maybe using RPA to improve their business processes?
Yeah, certainly. So the robotic process automation and artificial intelligence and machine learning are being used across the federal government. Appian today is in use in over 42 different agencies. To give you a few examples, your insurance applications for healthcare, the permitting process to get approval to go fishing. All these are different domains in which robotic process automation is able to help process a lot of that paperwork, and combined with machine learning and artificial intelligence allows the government worker to focus on much higher value tasks than just scanning documents.
My guest today is Michael Beckley, founder and chief technology officer at Appian. I'm your moderator, John Gilroy, on the discussion, Federal Insights. What's next for intelligent automation in the federal government? Sponsored by Appian on Federal News Network.